All right, we are going to do the last lesson of circles. There actually is one more lesson about circles. It's lesson 12.5. It's about the equations of circles. We are just not going to get to that, and so I will share that with Mr. Livesey that we didn't get to it, and when he does conic sections and does equations of parabolas and hyperbolas and all that, he will do equations of circles with you guys. All right, so we're talking about lesson 12.4. We did a little bit of 12.4 when we talked about angles of angles that are formed when lines cross. So when the tangents and secants cross, they form angles, and we did this lesson on angle measures. Well, the rest of lesson 12.4 is the segments that are formed when these lines cross. So here we've got two secants crossing. It only shows just the part that's in the circle. And we're not interested in these angles today. We're talking about these segments that are formed. And then here is two secants crossing, and we're talking about the segments that are formed. Here is a tangent line crossing a secant line, and there are segments formed. So today's lesson in 12.4, the rest of 12.4 is we're talking about segments that are formed and not angles that are formed. All right, so this box of 3 scenarios, it looks really confusing, and these rules are a little tough compared to the angle ones, so y'all just hang in there, okay? So here's what the theorem says. The theorem says for a given point and circle, so in this case it would be this point and this circle, this point and this circle, this point and this circle. So it's that same point of intersection that we talked about with angles. For a given point and circle, the products of the lengths of the two segments from the point to the circle are equal. So it's one rule, but there's 3 different scenarios for how that could look. Okay, so I'm going to try to explain to you what that says. It's complicated. All right, so when it's crossing inside like this, what it's saying is that from that point to the circle, on a given line, okay, so let me see if I can highlight this with different colors. Okay, so see this line right here, or segment, but it's on a line, right? There are 2 distances from the point to the circle. There's this distance D and this distance C. And on the other segment that's crossing it to form that point, it has 2 distances from the point to the circle. So here's a distance from the point to the circle, and here's a distance from the point to the circle. Well, it says the products of those 2 lengths, or distances, the products of those 2 lengths are equal. So these 2 lengths from the point to the circle, A and B, that product is equal to these 2 lengths from the point to the circle, C and D. So we get this A times B equals C times D. So I guess the moral of that story is, the shortcut version is, whenever they're crossing inside like that, the 2 segments on one line are, that product is equal to the product of the 2 segments on the other line. So A times B equals C times D. All right, now here's another way it could look. Okay, now this one is a little bit more confusing. That one's not too bad. If they all look like that, not too bad. But then look at this one. Okay, so remember we're talking about both segments. So let's just look at this segment. Okay, here's the tough part. There are 2 distances from that point to the circle. There are 2 distances from that point to the circle. One distance is just x. So from the point to the circle, that's just x. The other distance is from the point to the other side of the circle. So this is one distance, this is the other distance. That's x plus w together. So x times x plus w, those 2 distances, the product of those distances is the same on that segment as it is on this segment. So see, there's 2 distances here. The point to the circle, y, and the point to the other side of the circle, which is y plus z. So those two products are equal. So distance x times distance x plus w equals distance y times distance y plus z. That's what this says. That is tough. Way harder than this. See, these two distances are going different directions. So distance times distance, a times b, distance times distance, d times c. But here, the distances are going the same direction. Distance times distance equals distance times distance. That, I think, is hard. Okay, and this one is like that one, but just a little bit strange. Okay, so you know how there's two distances? Let's look at just this. So just like the middle one we were talking about, just like this one, from that point right there, there's, if we're talking about that blue segment, there's two distances to the circle. There's P, that's one distance, and then there's the whole way to the other side, which is P plus Q. So distance 1, P, times distance 2, P plus Q. Okay, well the other one, since it's tangent to it, and it doesn't pass through, there's only one distance. Well, you can't have a product equaling just that one thing. So they found out, after doing a little exploring, mathematicians discovered that if you take this distance twice, this product, this distance times itself, t squared, then you get that it's equal to the product of this distance times this distance. So if it only touches it once, you use that distance twice, you square it, and it'll equal the two distances on the other segment. Okay, now that right there, this isn't too bad, but that is tough, I think. So these problems look like each of those scenarios, okay? All right, so let's look at this one. So I would kind of model it after, I would find the one it looks like. Okay, this one looks like that middle situation. Okay, so here's what the rule is saying. On this segment, there are two distances from the point to the circle. From the point to the circle, one distance is 6. And from the point to the circle, the other distance from that point to that circle is 10, because it's that whole way. And they wrote it as x plus w, but we know the numbers. So that whole distance is 10. And then on the other segment, from that point to the circle, one distance is 7. And the other distance is this from the point to the other side of the circle. So that whole thing, it's not 7y, it's 7 plus y. So that's what our equation looks like. Okay, let's solve that thing. 6 times 10 is 60, of course. Distribute the 7, 49 plus 7y. I have a feeling this answer is going to come out kind of ugly. Subtract 49. And you get 11 equals 7y divided by 7. And the answer, y, is 11/7. Or you can write it as 1 4/7. Or if you like decimals, I moved my calculator, you can type that in and write that as a decimal. All right, so that's the rule right there. So distance to the circle times distance to the circle, 6 times 10, equals distance to the circle, 7, times distance to the circle, 7 plus y, or y plus 7. Okay, this one looks like scenario 3. So see, this side over here has two distances. From that point to the circle is 6, and from that point to the other side of the circle is 21. So 6 times 21. Oops, I said that wrong. 6 times 21. Okay, that's on the blue segment. And then since this one only touches it one time, we only have one segment, we are going to square that. You use that distance twice. That distance times itself, z squared. And so then when you multiply, you get 126 equals z squared, and then you square root. So z is square root of 126. Now they're probably going to want that as a decimal. I am going to grab my calculator. So square root 126. They will most likely want that approximated. So z is approximately 11.2. And make sure I multiplied that right. It's possible that they would ask you to simplify that radical, but probably not in this scenario. So that's about how long that is, 11.2. I'm going to go ahead and do this one too. 11 divided by 7. So about 1.6, approximately 1.6. And these we weren't given units, so these would just be units long. Okay, and then this is the easiest scenario. It looks like scenario 1. Okay, so see on this segment, there are two distances to the circle from that point. The point to the circle is 5 and the point to the circle is x. They're on different sides of that point, so it's a little easier to see. So distance to the circle times distance to the circle, 5 times x. And then on the other one, from the point to the circle, one distance is 7, and from the point to the circle, one distance is 3. 7 times 3. That one to me is the easiest one. And you get 5x equals 21 divided by 5. X is 21 fifths, or 4 1/5, or 4.2 if you prefer that, or if they tell you to round it, or, well, they wouldn't say round in this case because it's 4.2. Anyway, decimal answer is okay is what I'm saying. All right, so that is how to do the segment problems. These rules, they're pretty tough to remember. So like if you do a little practice with this and then you, I don't know, take a few months off and then come back and look at it, these rules are rules that a lot of people forget. You just don't use them a whole lot. So for that reason, I would keep for the year. We have 2 more lessons that I'm going to try to do to finish up, but not on circles. Going back to some stuff we skipped. But I would keep tip charts and notes. Okay, keep tip charts and notes so that you can look back at, especially these kind of obscure rules that you don't use a lot, in case you need to review a little bit for SAT type questions. All right, so that is all there is to the segment portion of lesson 12-4. Y'all have a wonderful day.